Hi guys, it's Mr. Robeson here. That's me waving at you from the corner over there. Exactly what I look like, I swear. Wearing that same outfit right now. So today we are going to calculate and interpret confidence intervals for proportions P. All right, so I promised it was coming. It's coming. All right, but first we need to get the Z star value. So we need to be able to calculate that because that was part of that formula for the margin of error. Z star was part of it. So what we do is, since we're working with a sampling distribution, which is normal, so since we have a normal sampling distribution, we can find the Z star values for 90% or 95% or 90%, 9% or any percent we want. That will be between negative Z star and Z star by using the inverse normal function. All right, and since these curves are going to be symmetric with 0 in the middle, since we're using the standard normal curve, like we're using normal with 0 and 1, our negative value will be the same value as the positive value. So we can just get one of them and say, okay, we got negative and positive. That's actually where the plus or minus sign comes from. So our interval really goes from there to there when we're making it. All right, so find the critical values for a 95% confidence interval. So that means 95% will be inside this interval. So this probability in the middle here is 0.95. So if we do 1 minus 0.95, that leaves us with 5% left over to split between the two ends. So if we divide that by 2, that gives us 0.025. So that's where this area is coming from and this area is coming from. It's half of that 5%, 2.5%. So then what we do is we do the inverse norm with an area of 0.025, just whatever's down here, a mean of 0, a standard deviation of 1, and that gives us our Z star value. It actually gives us the negative 1, so that gives us that negative Z star is negative 1.96. So we've been talking about 2 for 95%. It's actually 1.96. So that means Z star is 1.96 for 95%. And that's going to be the same anytime we want a 95% confidence interval. We're going to want to use 1.96. All right, now what about a 90% confidence interval? What are the critical values we use there? All right, well, we'll have a normal curve. Let's see if I can draw it on this pad here. That's not so bad. This time we'll have 90% in the middle, so it won't be out quite as far. Here's our middle, 0. So let's see, 1 minus the 90% leaves us with 10% to split between these two ends. So divided by 2, we get 0.05. So now we've got 0.05 and 0.05. And this would be our negative Z star. This would be our positive Z star. So we're going to use inverse norm with an area of 0.05, a mean of 0, a standard deviation of 1. And if we throw that in our calculator, we get that our negative Z star is negative 1.645. I know, I've got them memorized. You will too after you use them enough. And Z star would be positive 1.645. So we'd have to go up and down 1.645 standard deviations from the mean to get 90% in the middle or to get a 90% confidence interval. So that is a skill you need to be able to do. Later on, we'll also do this with t-distributions instead of just normal distributions. So there are inverse norm and there's something called inverse t that we'll talk about later. All right, so now let's find the critical value Z star for 99%. So if you think you can do this, go ahead and pause it, give it a try. I'm going to start by drawing my normal curve, 0 in the middle, 99% in here. So if we subtract the 99% from 100, we're left with 1% to split between the two ends. So we divide it by 2, we get 0.005. So we get 0.005 down here, 0.005 up there. This is our negative Z star. This is our positive Z star, our critical values. That's why we give that the stars. So we're going to do the inverse norm of an area of 0.005. The mean is still going to be 0. Our standard deviation is still going to be 1 because we're looking with the standard normal curve. Even if we are working with actual values, we still use 0 and 1 here for our standard normal curve just to get the Z star. All right, and if we plug that all into our calculator, we do second variables, number 3, 0.00501, press enter, press enter, press enter again. We get that our Z star is equal to 2.576. All right, it's actually, our negative is negative that, but our positive is going to be positive. So we get for 99%, 2.576. Always for 99% for z's. All right, so now that we know how to make the interval, now I'm going to show you the process we use to organize and do these tests. And it's always a 4-step process, and everything we do for like the rest of this school year is going to follow this 4-step process. State, plan, do, conclude. In fact, whenever we have these inference problems, I suggest on your paper you just draw a big old cross, and then just know you've got to fill in all 4 of these boxes. And in this order: state, plan, do, conclude. So 1, 2, 3, 4. Makes sense that conclude is at the end, right? Conclude. Well, oh well. All right, so first we're going to state some stuff. We're going to state what we know. We're going to state, what does P stand for? All right, what are we trying to estimate? All right, we got to say what we're trying to do here. We want to state our confidence level. What does C equal? And we're going to state any knowns. Like if we know n or p hat, we can write it as a fraction. That's fine. If we know p, that's fine. We give that. But n and p hat are really what we want there. So what does p stand for? P is the true proportion of, and then whatever it is we're trying to find. Then we'd write C equals, I don't know, maybe 99%. N equals, I don't know, whatever it is, 50. P hat equals 12 out of 50. I'm just making up numbers here, but that's what we would do in this box. That's all we're looking for. The next box, we want to state what we're doing. So we're going to learn lots of different confidence interval methods, and we're going to learn lots of different hypothesis tests. So we need to state the name of this test. This is a 1 sample, because we're only working with 1 sample. Always start with how many samples we're working with. 1 sample. And then we're going to say Z interval, because we are finding an interval, and we're using Z scores, Z star, right? So we're just going to say Z interval. You can put a dash here if you want. For P, proportions. We're working for proportions, so we'll say for P. If we were looking for mean, we'd say for mu. We'd write mean or mu. And then we check the conditions. This is our planning stage. So we're planning for this test. We have to check the conditions. Do we have a random sample? If it's stated in the question, say stated. All right, is it approximately normal sampling distribution? We got to check both of these conditions, and then after they're both good, then we're going to write approximately normal sampling distribution. Next, we're going to check our independence condition. Is n less than 10% of the population? And you actually just write this, independence colon n less than 10% of, and write what your population size is, and then just put a check mark after it. That'll do. All right, in box 3 down here, we're going to either write out the formula, do the calculations, like p hat plus or minus z star times the square root of p hat times 1 minus p hat over n, and work that out. Or this is built in on our calculator. So there's a way to do this in the calculator. I'll show you here in a little bit. And we're just going to write out what the output is from the calculator. And then step 4, we're going to conclude, not conclude. We're going to write out the sentence. So we went over the sentence in 7.1. We are blank % confident that the interval from blank to blank captures the true proportion or population proportion of, and then we throw in some context. Remember, always be specific, always throw that context in there. All right, so here's an example. A recent poll of 800 randomly selected cell phone users found that 200 of the respondents admitted to walking into something or someone while on their phone. Admit it, you've probably done it. I've done it. Construct and interpret a 95% confidence interval for the proportion of all cell phone users who would admit to walking into something while talking on their phone. Why am I underlining this? This is what P stands for. So in our state, P is the true proportion of cell phone users. You can say all if you want to. Who would admit to walking into something. I know it's kind of tedious writing out all this stuff, but you want that 5 on the AP exam. That's what you got to do. Or someone, I'll leave that off, while on the phone. All right, now we want to write down what else we know. So our confidence level, 95%. Our sample size n, 800. Our p hat, how many said yes? 200 out of 800. All right, if you want to reduce and say that's 0.25, that's fine. You can do that. Next, we're going to plan. So let's see, how many samples do we have? We're doing a one sample. All right, we're working with Z. We're finding an interval for a proportion, so for P. Next, we check our conditions. Did we have a random sample? Let's see, a poll of 800 randomly selected cell phone users. So we're going to just say random sample stated, and I underlined it up there. If you want to draw a line from here to here, you can do that. They have to check everything on your AP exam, including if you draw lines. Next up are approximately normal conditions. So we're going to do n times p, or p hat actually, gives us 200, which is greater than or equal to 10. Yep. And then we've got 800 times 1 minus 0.25, which is going to give us the rest of this. So 800 minus 200 is 600, also greater than or equal to 10. So we have our approximately normal. I get that this is long, it's okay. Sampling, distribution. The good news is if these problems are long, I can't give you a ton of them to do for homework. And finally, the independence condition. Our n is 800, which is less than 10% of all cell phone users. Right, because that's what we were talking about. That makes sense. There's more than 8,000 of them. That works. All right, so we've checked all of our conditions, so our planning phase is done. Now we're going to perform the calculations. So we can actually do this out by hand, or we can go to the calculator. The calculator is probably the easy way to do it. If you do it out by hand, it's 0.25 plus or minus z star. The z star for 95% is 1.96 times the square root of p hat, 1 minus p hat, over n. And then we'd have to work that all out. If we do this on our calculator, and I want to show you how to do that, we turn it on. We go to stat. We go over to tests. First time we use the test in it. And we want a, let's see, we're not doing a test, we're doing an interval. And there it is, one proportion z interval. So one prop z interval is what we're doing. I'll write that down. One prop z int. Do not write that for the test name. The AP exam does not accept that for a test name, but if you want to write it in the do section to say what you're doing, that's okay. So we're going to put in the numbers. We've got 200 for x. We've got 800 for our sample size. 200 were the ones that said yes. That's what we're looking for. Our confidence level is 95%, so we put 0.95, not 95. It's a decimal. And we press calculate. And then we write down what it gives us. So we've actually already written down p hat and n, but if you want to write them down again, you can. The interval is what we really want. So from 0.2199, maybe just 0.22, to 0.28001, so maybe to 0.28. So we can just say 0.22 to 0.28. There's our interval. And now we conclude. We write our sentence with context. So we'd say our confidence level was 95%. So 95% confident that the interval from 0.22 or 22% to 0.28 or 28% captures, there's our verb, it captures something, and what it captures is the true proportion or the population proportion of cell phone users who would admit, it's basically we're restating this here, would admit to walking into something. I understand it's a lot of work. I get it. Writing out a sentence. At least you don't have to think about the sentence. It's just writing the exact sentence. So walking into something while on the phone. I'm literally just restating what we said right here, or in this sentence right here. And that's it. I understand it's a lot of work, but it's not hard work. It's all very basic steps. You just have to remember all the steps, and that's it. So here's the calculator buttons if you want. So it's the test, and then it's A, one prop Z interval. We put in the numbers. There it is. So this only works, this only gets you through the do step. So you still have to do the state step, the plan step, and the conclude step. All right, on the AP exam, they usually break this up into 3 different parts. The state and the plan section go together. The do section is one section, and the conclude section is another section. All right, so here's another example. So if we want to find an 90 or an 80% confidence interval for this guy, we would have to go through all the checks and balances and stuff. But if it's a multiple choice question, we don't have to go through all that stuff. We can just go to stat, go to test, option A, one prop Z interval, just put the numbers in. So we've got 170 are against uniforms out of 200. So we'd put in 170 out of 200. Our confidence level is 80%. It's kind of a weird confidence level, but there we go. And there's our answer, 0.8176 and 0.882. Well, there's a 0.882 right there, 8176, 818. Yep, that's it. All right, so that's how we can find confidence intervals real quick. Ordinarily, if it's a free response, you have to check everything. If it's a multiple choice and they just ask for the interval, just go straight to doing the interval. All right, and how we would interpret this. Well, we'd start with we are 80% confident. Okay, they all have that. That the interval from that to that. The interval from that to that. I left out the word the here. Oh well. It's like, why is that one longer? Captures the sample. No, it doesn't capture anything about the sample. The true proportion, yep, of students for school uniforms, of students against school uniforms. So we were going for against. So we want the one that has against. So our guy here is C. And we just need the word the in there. There it is. All right, and that's it for this one. Next one, we'll come in and we'll take a look at finding minimum sample size using margin of error.